Alrighty, ladies and gentlemen of algebra, you're looking at 9.5, talking about dividing rational expressions. So, learning target is I can divide a rational expression. So now, when you're looking at this, dividing is exactly like dividing fractions. You multiply by the reciprocal. Flip the second expression and multiply. Okay, so when you're looking at one like number 1, you see that it's division, so you got to flip over the second sign. So the first one stays the same, 5x squared over 7 times 21 over 10x to the third. So now it becomes a matter of simplifying, much like we were doing for multiplication. So 21 over 7 is the same as 3 over 1. Now 5 over 10 is the same thing as 1 over 2. So x squared over x cubed, well, 2 minus 3 means that's going to go away. That's just going to become 1. Okay, so I know this gets a little messy, but what do I have left up top? Well, I've got this 1 and this 3. Everything else got canceled out, so I'm left with just 3 on the top. On the bottom, I've got a 1, I've got a 2, and I've got 1 remaining x. So that means I'm going to have 2x. So what's my excluded values? Well, my excluded value is just going to be, you know what? X cannot equal 0. That doesn't work. So there's my simplified solution with my excluded value. Now, number 2. Same kind of idea. Keep the same. Keep the first one the same. Flip the second one. And now see what you can do. So, start thinking about some things here. One is, I can't really do a whole lot with the numbers right now. Okay, I've got 27, 11, 2, and 9. So I might actually have to multiply the numbers together to kind of figure out what I can do. But let's kind of come back to that. So here I've got d squared, d to the third on top. So d squared and d to the third are on top. And just a d is on the bottom. So I can kind of combine these two, and that becomes d to the fifth over just this d. So that's going to leave me with d to the fourth in the numerator. All right, so that takes care of all the d's. C's, I got a c to the third up here. I've got c to the third here and a c to the third here. Well, those two are going to completely cancel each other out, so I don't do anything with that. What I've got left is this e right here, but that doesn't go with anything else, so I'm just going to have e on top. So now back to the numbers. So 27 times 9 is going to give me 243. And on the bottom, 2 times 11 is going to give me 22. And I've got nothing else left in the bottom. So that's as simplified as I can make it. So for here, for this one, there are no excluded values. Okay, d and e can be whatever they want. All right, so number 3 here, same kind of idea, but look, now I'm dealing with binomials. Okay, so I keep just like before, keep the first one the same. Actually, I want to factor that. Factoring just makes my life easier. If I can factor and go, then my life can get easier. So I'm going to factor this 2b plus 2 into 2, and then times b plus 1. Flip it over, but if I factor this, I get 3b plus 4. So now all of a sudden I've got things on top and bottom that I can go away. So this 3 plus 4 cancels out. This b plus 1 cancels out with that one. So on top, I'm not left with 0. This is technically 1. But on the bottom, I've got 2 times 3, which is going to be 6. So after all that, it's simplified to 1/6. For number 4, same kind of idea. I want to start factoring as fast as I can. So that top one becomes 6 times b minus 2. Bottom one, 3b plus 5 times b plus 5. Then on the top, 2b plus 18 becomes 2b plus 9. So now, take a look. Okay, b plus 5 cancels out. 6 over 3 becomes 2. But look, 2 over 2 cancels out. So I'm left with b minus 2 over b plus 9. Nothing else can cancel out. I can't just cancel out the b's. Everything goes together here. The b minus 2 and the b plus 9 go together. So don't try telling me that it's negative 2 over 9. You will be wrong. This is going to be your final answer, your simplified expression, and my excluded value is going to be negative 9. B cannot equal negative 9. So there's my answer. So here, same kind of idea. Let's take a look. So factor top, so that's going to be x plus 2, x plus 1 over 4 times x plus 1 over x plus 2. So look what cancels out here. Make sure, again, this is division, so I have to flip-flop these two. So x plus 2 cancels out. On top, I'm left with x plus 1, x plus 1. On the bottom, I'm left with 4. So leave that as it is. There's no excluded values. No excluded here because my denominator, x can be whatever it wants because my denominator is always going to be by 4, and that's fine. For number 6, this can be factored. This is actually x plus 2, x minus 2 over 5x. Flip the second one, x over x minus 2. So x minus 2 cancels out, x minus 2 cancels out. I have just an x and I have just an x. That cancels out. The 5 still remains. So I've got x plus 2 over 5. There's my answer. Again, no excluded values because it's always going to be divided by 5. So things get a little trickier here. So now factoring 2x plus 2 over, this is going to be x plus 9, x plus 2. And again, if you need to take a minute and factor that, do it. So now I flip-flop these. So on the bottom I have x plus 1. On the top I'm actually going to have x plus 3, x plus 2. So now play the canceling game. Well, this cancels, this cancels. Okay, and that is about all I have. I can't cancel out both. You see I have the x plus 2 over here. I can't cancel out both. Only one can cancel each other out. So I'm left with 2x plus 3, x plus 2 over x plus 9, x plus 1. So here my excluded values are going to be kind of the opposite of what's here. So it's going to be x cannot equal negative 9, x cannot equal negative 1. So there's my simplified answer with excluded values. So here's my excluded values right here. Can't be negative 9, can't be negative 1. For number 8, so factoring again all over the board, so x plus 2, x minus 1, that's this one, over x plus 3, x plus 2. So remember when I said factoring is going to be important and it shows up again, look, this is all factoring. So x plus 3, x plus 4, that's this one now going on top. This one's going to the bottom. So that's going to be x plus 3, x minus 1. So again, if you have to set up x's, do what you got to do. So now a lot of stuff cancels out here. I can go x plus 2, x plus 2, x minus 1, x minus 1, x plus 3, x plus 3. I'm left with x plus 3 and x plus 4. X plus 4 goes on top. X plus 3 goes on bottom. X cannot equal negative 3. There's my answer. All right, so in April 2001, NASA launched Mars Odyssey spacecraft. Took 200 days to travel 466 million miles from Earth to Mars. What was the average rate of speed of the aircraft in miles per hour? So it took 200 days to go this far. They want it in miles per hour. So you take 466,000,000, okay, that's miles, divided by 200. So that's going to be 233 0, 0, 0, 0. So roughly $2,330,000 per day. So that's miles per day. So they want hour. So basically this is what's your speed per hour. So how many hours are in a day? 24. So I'm going to divide that by 24. So divided by 24. So that becomes 97,083.3. So about 97,000 miles an hour. That's moving pretty fast. All right, so same kind of idea. Assuming that the opportunity to travel the same distance as the Mars Odyssey spacecraft, but it did it in... So it went from 2003 to 2004, so July to January. How fast did the opportunity travel? So you got to take a minute to figure out how many days is it from July 27th to January 25th, 2004. So let's see, July 27th. Hold on one second. Okay, I'm back. Just a quick calculation. That is 202 days from July 7th to 2004. So round to the nearest mile per hour. So same distance. 466 million, except now I'm going to divide it by 202. So then that's going to be a really, really big number. So 230,693.0. So that's 2 million per day. So per hour, I want to divide it by 24 again. So that's going to be 96,122.1. So roughly 96,122 miles per hour. Okay, that's all I got. Come talk to me with questions.